For most of human history, food was eaten raw. No flames, no pots, no seasoning. Just whatever could be torn, chewed, or swallowed directly from the world around you. If you were a human living 2 million years ago, your diet looked nothing like anything recognizable today. You ate roots, berries, raw meat, and insects. Digestion was slow and difficult. Your gut worked overtime just to pull enough energy from each meal to survive another day. And yet somewhere along that long, brutal timeline, something shifted. A human encountered fire, and instead of fleeing, they stayed. They put food into it. That single discovery may have fundamentally changed what humans are, not just culturally, but physically, at the level of bones and brains and teeth. The oldest direct evidence for cooking comes from a site in South Africa called Wonderwerk Cave. Researchers found ash, burned bone fragments, and charred plant material inside the cave dating back roughly 1 million years. That pushes the record of controlled fire use deep into human prehistory, long before modern humans even existed. The species living there was likely Homo erectus, an ancient human relative with a smaller brain and a considerably larger gut than ours. But the evidence at Wonderwerk wasn't just fire. It was fire used repeatedly, inside a shelter, in the same location over and over again. That matters enormously. Fire happening once is accident. Fire happening again and again in the same sheltered space is deliberate behavior. That is something entirely different. Here is where the story becomes genuinely strange. Some researchers believe cooking began even earlier than that, much earlier. The anthropologist Richard Wrangham proposed something called the cooking hypothesis. His argument is remarkable. He suggests that cooking didn't just change human culture, it changed human anatomy. Think about what separates humans from other great apes. Tiny mouths, small teeth, weak jaw muscles compared to chimpanzees, dramatically shorter guts, dramatically larger brains. Wrangham argues that none of this happened randomly. Cooked food breaks down plant fibers and denatures proteins before the meal even enters your mouth. Your body extracts far more energy from cooked food than raw food, using far less digestive effort to do it. The numbers behind this are striking. Studies on animals fed raw versus cooked meals showed subjects consistently gained more from cooked food, even when calorie content was identical on paper. Cooking essentially predigests food before it ever reaches the stomach. A human eating cooked food gets significantly more energy from the same meal than one eating it raw. Energy is everything in evolution. More energy means more brain growth. More brain growth eventually means better tools, larger social groups, and broader cooperation between individuals. If Wrangham is right, fire didn't just warm early humans, it built them into something new. One particularly telling aspect of this transformation involves what researchers call the thermal efficiency principle. When early humans applied heat to tough plant fibers, the heat broke down cellulose walls that would have required hours of chewing otherwise. A human chewing raw fibrous plants spends significant energy in the act of chewing itself. Cooking transferred some of that digestive work to the external fire instead. The caloric savings were substantial enough to matter across a lifetime. Young humans, pregnant women, and individuals recovering from illness all benefited disproportionately from cooked food. This selective advantage meant populations with controlled fire gradually outcompeted those without it. Within a few 100,000 years, the practice spread across continents, carried forward by every generation who understood fire as simply essential to survival and growth. The timeline he proposes is deeply controversial. He suggests cooking may have begun as far back as 1.8 million years ago, coinciding with the appearance of Homo erectus and a dramatic reduction in tooth and gut size visible in the fossil record. Direct fire evidence that old is nearly impossible to preserve. Ash scatters. Organic material dissolves across hundreds of thousands of years. So the absence of ancient fire evidence doesn't prove fire wasn't happening. It may simply mean the evidence didn't survive long enough to find. Scientists on both sides of the debate acknowledge the fossil anatomy is real. They disagree sharply about what caused it. What is far more certain is that by 400,000 years ago, fire use was widespread among early humans across multiple continents. Sites in Israel, France, and South Africa all show evidence of repeated controlled hearths. Neanderthals, the closest relatives of modern Homo sapiens, were almost certainly cooking. Their dental wear patterns, hearth sites, and carefully butchered animal bones all point toward regular food preparation using heat. Neanderthals were not primitive brutes moving blindly through the world. They made sophisticated tools, they buried their dead, and they cooked. By the time modern humans appeared around 300,000 years ago, Fire was already deeply woven into daily life. What did early cooking actually look like? Probably nothing resembling a meal by any modern standard. No clay pots existed yet, no controlled ovens. The earliest cooking was almost certainly direct contact with embers, meat placed directly on coals, roots buried beneath hot ash. The heat softened tough plant material and made animal protein far safer and easier to chew. Tubers, which are starchy underground roots still eaten across much of the world today, are nearly indigestible when raw. Cooked, they become a dense and reliable calorie source. Early humans living on African savannas had access to enormous quantities of these roots. Cooking them transformed a difficult food into a genuine staple. Fire also changed the social structure of early humans in ways that rarely get discussed. Cooking takes time. You can't simply grab and run anymore. You gather ingredients, you prepare them, you wait near the flame. That waiting created something genuinely new. Communal meals, groups sitting together around shared heat, eating at the same time, in the same place. Some researchers believe the hearth was the original social institution. Before villages, before written language, before any recognizable civilization, there were groups of humans sitting together around fires at night. That is where early storytelling almost certainly began, where alliances formed, where knowledge about hunting grounds, seasonal foods, and approaching dangers was passed between people. The campfire didn't just feed ancient humans, it connected them. There is also evidence that cooking changed how humans slept. Our ape relatives sleep in trees for safety, which is uncomfortable and physically limiting. Once early humans controlled fire, large predators became less dangerous at night. A burning hearth kept carnivores away. Humans could sleep on the ground, in larger groups, for longer and deeper periods. Better sleep improves cognitive function. Better cognition means better planning, better tool design, and better coordination between individuals. The ripple effects from a single behavioral shift, placing food near a flame, may have been nearly endless across generations. By around 30,000 years ago, humans were using far more sophisticated preparation methods. Groundstones for processing seeds and grains appear across multiple archaeological sites. Evidence of boiling using heated stones dropped into liquid-filled containers made of animal hides suggests humans were experimenting with cooking techniques long before pottery was invented. You wouldn't necessarily guess from the tools alone how inventive early humans had become around fire, but the variety of techniques appearing across different regions suggests cooking had grown genuinely complex. Different cultures, different landscapes, different solutions to the same fundamental challenge of making food safer and more calorie-dense. Pottery changed everything again. The earliest fired clay vessels appear around 20,000 years ago in China, predating agriculture in that region by thousands of years. With pots, you could boil water reliably and hold heat over a sustained period. Foods that were otherwise difficult or mildly dangerous to eat raw became accessible. Legumes like lentils and beans contain compounds that are harmful when uncooked. Prolonged boiling neutralizes them entirely. Seeds too hard to chew became soft and edible. Ceramic vessels didn't just improve cooking, they dramatically expanded the range of foods humans could safely consume, which directly expanded where populations could settle and how large communities could grow. The story of cooking is ultimately a story about energy. Every major shift in human prehistory, larger brains, permanent settlements, population growth, long-distance trade, traces back in some way to humans finding better methods of extracting more calories from the world around them. Fire was the first, and arguably most consequential step in that entire chain. It happened slowly and unevenly. Different populations likely discovered and developed fire use independently across vast stretches of time and geography. But the direction was always the same, toward heat, toward prepared food, toward meals shared around a flame. And tonight, whatever you're cooking for dinner, whether it took 5 minutes or 2 hours, you are doing something your ancestors began doing more than 1,000,000 years ago. The specific ingredients change completely. The act itself never did.